Start maths now. Last lesson, I just double checked whether you remembered how to list probabilities, how to grid probabilities, how to draw tree diagrams. I said that was assumed knowledge. I'm just going to assume that you can do that now. We're going to chuck numbers into your probability now. So, first thing is definitions. In normal speak, the theoretical probability of an event is the chance of that event occurring from just observation, not actually carrying it out. So if I looked at a coin, what is the chance of getting a head or tail just theoretically? 50-50. Is there a very high chance that if I flipped a coin twice, I might get two heads? See? So there's a difference between the theoretical 50-50 and actually doing it. But do you agree that if I flipped that coin many, many times, what do you think? Is there going to be a big difference between the theoretical and the experimentation, or is it going to get closer and closer to the same? What do you reckon? Someone whispered it. It should get closer and closer. Because if I just did it once off, I might get a 100% chance of getting heads and heads. But if I did it 1,000 times, it's highly likely that I'd have 500 heads, 500 tails. Okay? We don't do much experimental probability at year 10. So the proper definition that you need to be aware of is really this formula, but there's a lot of assumptions. We need to assume all outcomes in a sample space are equally likely. And by definition, an event is when we get an outcome or outcomes that we're interested in. Then finally, the theoretical probability of an event occurring, which we label PE, is given by this formula. So I'm never going to ask you just to give me a definition. I wrote the test. What you'd need is this formula here, which is PE, standing for the probability of the event E, is equal to the number of outcomes that correspond to E divided by the number of outcomes in the sample space. Can you please get this rectangle here? You get a cheat sheet. It would be suggested that you have that on your cheat sheet. The probability of an event E is the number of outcomes corresponding to E divided by the total number of outcomes in that sample space. Does anyone remember any notation from last year where you had P and the letter with an apostrophe over it? The teacher might have called it PE dash. If not, I'm covering that. Just so that you're aware, if you see this notation here, PE, but there's a little apostrophe above it, that is notation for the probability of E not happening. So PE is the probability of an event happening. PE dash, I say dash because that's the colloquial term in maths, but it's an apostrophe. PE dash is the probability of it not occurring. So if I had a 75% chance of winning the lotto, what's my chance of not winning the lotto?
25.
Good, because the probability of the event not occurring is 1 minus the chance of it occurring. Okay, if you've got this, can you please get this little reminder down? I'll give you a minute or so to get that. Start having a think about this example with the 3 coins tossed at the same time. Can someone remind me how I list a sample space? What do I draw? What kind of brackets? Curly ones? Anyone maybe off the top of their head know how many different combos we're going to have for flipping the coin? 3 coins. Good. How did you get that? I'm just curious. 2 cubed. So, yeah, okay. Maybe you were taught fine last year. A coin has 2 different possibilities, heads or tails. If you're doing it 3 times, you cube that number. 2 times 2 times 2 is 8. So let's do this systematically. Heads, let's start with heads, heads, heads. Comma, what's another thing that I could do?
Heads, tails.
Good, so I like that you're keeping it as much heads as possible and just changing the end one. What would another one be?
Heads, tails, heads.
Heads, tails, heads. So we're doing with that. And something else, someone, yeah, you go.
Heads, tails, tails.
Heads, tails, tails. Now this is going out of sync with my systematic, but it doesn't matter. All I care about is that we get the right answer. Someone else. There's a freaking other.
Tails, heads, heads.
Tails, heads,
Tails, head, tails.
tails, heads, tails. Anyone else from tails? Me personally, I would put it at the end there. That's my OCD. How many are we at now? 1, 2, 3, 4, 5, 6. Tails, tails, heads. Okay. Find the probability of getting 3 heads. So this is where we use this formula. The event that I want is 3 heads. So P, 3 heads in brackets. It's no longer E. How many of these events in the sample space correspond with the event that I'm interested in? One of them. It's just this one here. Just the one on the far left. So what's gonna be the number that goes on top of the fraction? 1. There's one event that corresponds with what I'm interested in. How big is the sample space? 8. 1 over 8. We're more advanced maths here. Leave it as a fraction. It's more accurate. Or you could grab a calculator and go 1 divided by 8. I think it's 12.5. 0.125. Who are you after?
Hi, Mr. T. 5 minutes or less. Thank you.
Next, this one's slightly more complicated. Is there only one way of getting at least one head? How many? Does anyone disagree? Anyone speak now or forever hold your peace?
7 over 8.
At least one head means I care about getting one head or above. The only way that that's going to happen is everything except this one. So how many events correspond with the thing that I care about? 7 over 8. That's not going to be a nice number. 7 divided by 8. 0.875.
Is everything except tails, tails, tails.
Which you could also write as P 3 heads dash. Okay. A minute or so to get that example down, please, and then we'll move on. Can someone remind me I need to edit the name out of the... You said it's so loud as well. I need to edit that name out of the video. Huh? What? That's that example down now. Can you have a look at the next one, a custom dice? I'll leave that up there. Custom dice has sides numbered 0, 0, 1, 1, 4, and 5. I roll it twice. Draw a grid to represent the sample space. Why are we using a grid? There's 2 aspects to this. I'm rolling it twice. So what could the 2 axes represent? Roll 1.
Roll 1 and roll 2.
Roll 1 and roll 2. What would I put along the numbers of that axis? What are the outcomes of those dice? Our custom dice. 0, 0, 1, 1. 4 and 5. I do the same because you're rolling that same dice twice. What makes a grid? The little dots. Yes, I am doing I'm doing 36 dots in front of you because that's exactly what I expect you to do to get full marks for the grids question in your test. That is A, done. Find the probability of getting a total of 5. This is a little harder. It's not as simple. Am I circling more than one thing to get a total of 5? How do I get 5? 1 and 1, is that going to get me 5? What do I need to combine to get 5?
1 and 4 or 5 and 0?
1 and 4. Is this also 1 and 4 here?
Yep.
So I'm going to circle everything that corresponds to that 1 and 4. 1 and 4. Is there other ways of getting 1 and 4 here?
Across the up and if you go
Here
up.
and here?
Yep.
Is there ways of getting 5?
5 and 0.
Whereabouts is that going to be?
Top left and bottom right.
Top left, 2 of them. Why? Because we got 2 zeros here.
Same
And
thing, bottom right.
are those the only ways that we can get 5s? Total of 5?
Yep.
Hopefully we can add. So P total 5. equals. How many outcomes are there associated with the event that we're interested in? 1, 2, 3, 4, 5, 6, 8 over how many total events are there? 36. 8 divided by 36, we have 0.22 rounded to 2 decimal points. That is your answer. That's 2 marks. Mark for filling this in correctly. Mark for getting the answer. 2, getting 2 numbers that are the same. This might not be as easy as you would like. Where would I move my cursor from here to start highlighting getting the same number?
All the way to the center.
I like that. He's finding shortcuts for that. All the way through the center, because we're talking matching. So 0, 0, 0, 0, 1, 1, 1, 1, 4, 4, 5, 5. Are those the only ways of getting matching numbers?
And then because you have doubles of certain numbers, you can go slightly off the side of that line.
Yes, sir. We have a little square here. Where else is there?
Down in the middle as well.
The ones, we have 1, 1, 1. Nice little square there. Anything else?
No.
So what do we have? 8, 9, 10. Probability of 2 same. 10 over 36. 0.28 to 2 decimal points. All right, I'll stop there for a little bit to get that. If you get it, then don't bother copying it down. I'll give some time there. I'll give till 22. This Venn diagram one's a doozy though. It's kind of complicated. I had to work it out. Oh no, I sweated it off. Let's see if I can. That name was said pretty early on, wasn't it? It was when I wrote that fraction something, I think. Is that pretty logical, that?
Yeah.
Give one more minute. I said I was going to give time, so I'll leave that time. Please use that finance and this last test as a way to push your grade up. It's straight year 10 maths, you should be able to dominate it. If not, I won't be angry, just disappointed. Okay. If you need to scroll up later, do it after the video. This Venn diagram one is a little doozy. In a library, groups of 50 readers, 31 like science fiction, 20 like detective stories, 12 dislike both. I want to draw a Venn diagram to represent this info. So I'm going to put my science fiction here, my detective stories there. The universal set is the rectangle. There is only one number that I can write straight away. What is the only one number out of those?
The 12 outside.
The 12, where is that going to go?
In the rectangle.
In the rectangle. I have not given you any formula to work out Venn diagrams. You're an Ignite, you need to use logic and reason to work this out. Because none of this info here directly tells you what goes into any one of these shapes. And I give you 30 seconds to, you can talk to the person next to you, don't say their name though. What approach could we use to work out where those numbers go? Because you might have a better approach than mine. Mine works for me, but there's no set steps to it. Go, 30 seconds. How do you work it out? I'll show you mine, but if you have a better way.
It's not. Toss out and line. It's perfect.
I'm confused.
Yeah, it's not straightforward.
No, it's
You're the worst thing. Trying to figure out how many go in the S column, how many go in the D column, and how many go in the F column.
Or I'll bring you back. Does anyone have an approach for that works?
I do, but I don't know how to articulate it. Yes.
Maybe get back to me after. This is how I personally did it. The only thing that we definitely know is 12 is in the rectangle. Therefore, is there a way that I could work out how many things would go in all of the circle?
Yes.
What would that be?
Do 50 take the 12?
Good. So that was the thinking that I did, is that within this, I don't mind what you write for working out. There should be 38 in there. Okay? What was what could we do next? Did you have a next step?
No.
Okay. This is where I spent a little time in lesson 5 trying to work it out. This is what I did, because there's no steps here. All I know is that 31 like science fiction and 20 like detective stories. But do you agree that that's wrong right now?
Yes.
Because right now there's 51 versus
It's meant to be 38.
38. So, what could I do there? Yes?
You could add the 31 and the 20 together and subtract the 38.
Yes? Because there's far too many. So what do we have? 51.
Minus 38 equals 13.
Good. So that's the overlap. That's what's going to be the overlap, is the 13 in the middle. Right?
And so you just have to take 13 away from each.
Exactly. So because there's 13 in the middle, determined by that overlap, 20 take 13 is going to be 7 and 18. That's what worked for me. Okay, and then I would take the time to erase this. Because that's not part of it. So we've worked out the Venn diagram for that. Now we can work out probabilities. 1 likes science fiction and detective stories. Which part of this is likes both?
The overlap.
The overlap, so probability S and D is going to be 13 out of 50. That's going to be a fraction of some sort. 13 divided by 50, 0. I'll just do it to the side, 0.26. 2, probability of either. Either is an important word here. That's why you need to actually know English, because you can't answer the question properly if you can't. Either S or D. What region represents liking either of the options? It's very specific. What?
S or D?
S or D, so you're saying this and this, but
Yeah.
not the middle?
Yes.
Good. So 18 plus 7 is going to be 25 out of 50. There is a 50% chance that they like either S or D. Okay? Maybe if that Venn part was tricky, it may be useful for you to get down the thinking there. But I'll give you some time. We have one more example. What you'll find is you won't have much time to do exercises today. That's fine. You can finish it off Wednesday. Teaching's more important to me. I'd rather be able to turn around and say I taught the thing than not. Question? Was there a question there? That's the Venn diagram example. One about languages, and then we'll shut our mouth. This is reading off of a table now. I wanted to say, please don't say the name. It just goes, boom, name, super loud. Last one, example 4. The table below shows the language studies studied by people at language school. Find the probability that a randomly selected person from the school is female, is studying French, is male but not studying German. We can't answer any of these right away. Because in your formula, what does the number on the bottom represent? The total. Do we have any totals here yet? What could I write for the male total? Do I need to extend these?
40.
40. What will the total be for females?
45.
Is it?
I think so. Yeah.
Let's double check.
I don't think so. Could be. No,
It's not that I don't believe you. See 43.
Oh,
43. Just take your time.
No, that makes sense.
It's fine. I suck at mental arithmetic too. That's why I check the calculator. I'm not saying that you do. Like that. It's just always good to check because you have the facility too. Now that's total French. What do we have?
32.
32. Total of German,
24.
24. And
27.
what would I have here in the bottom corner? The total number of students at the school.
83.
This column here should be the same as that as far as I'm concerned. Okay, so let's check that that's the case. 40 plus 43 is 83. Let's check 32 plus 24 plus 27, 83. Okay, we did our maths properly. So now we can start answering these because the first one is a probability that they're female. So the sample space is all 83. How many females there? 43. See how it just depends on how you're looking at the table. We couldn't answer this without adding the additions there. 43, so probability 43 over 83, 0.52 to 2 decimal points. B is studying French. P, French. What number?
32.
32 out of?
83.
Decimal of some description. 32 divided by 83, 0.39. Last one for today. C. This is where it's, and this is the tricky part. Is male but not studying German. What part of the table am I looking at?
Male, French, and Italian.
So I need to look here, this column, and here. So I need to add the 32 and 27, which would be...
No, you
No,
wouldn't do
that's
that.
more
'cause
14
it's
level
only
males.
There's female as well, if it's so.
Oh, yes, I see. So 14.
It's just 14.
Okay, you got me. P. Anyone else, I'd be like, hey, I was just testing you. Well, no, P, male, but not German. What do we get? What number would go on top?
25.
25 over
83.
80. I don't agree with the 83 because that 83 encompasses studying German. They're not studying. They are not studying German is a condition on it.
But then also
It's a
does
probability,
not count the
yeah.
Is it
female
not a
students.
probability?
It's a probability of picking any random person from the school, so that includes French, German, or Italian students.
Because otherwise someone would need to
From
do
the way you've
female
worded the
ones
question.
different.
No, yeah, it's because of the freaking comma. Okay, I agree. So where we got 25 over 83. 30%, 0.30 to 2 decimal points. Okay. I'll stop the video there.